Hello everyone, hope you all are doing great. I am Preeti, your host, and I'm excited to welcome you all to the session on Introduction to Kubernetes Pods and Deployments. Now I am delighted to introduce our speaker, Mr. Rahul. Rahul is a cloud and DevOps leader with deep expertise across AWS, Azure, and Oracle Cloud. Currently heading CloudX at Winfo Solution, he focuses on driving digital transformation through innovative cloud native solutions. We are truly excited to have him with us today to take us through this insightful session. Let's give a warm welcome to Mr. Rahul. Over to you, sir.
Hello everyone, I hope I'm audible and thanks Preeti. Thanks for introducing me. So I hope everyone is doing great. So let's start with our session and let me share my screen. Is my screen is visible?
Yes, it is visible.
All right. So we are going to discuss about Kubernetes today. But before that, I will take few minutes to give you the context, right? What is this? I'm not going to tell you directly what is Kubernetes, what kind of problem it solves, what are the use cases. First, let's try to understand why we need this kind of a tool, right? So this from we'll start from there. So anyone has ever ordered pizza online? Any one of you? I think most of you, right? Everyone order pizza online. So let's deliver this particular application with this particular example. Okay, say for example, I just want a confirmation my whiteboard is visible. You are able to see the drawings, right? Okay, Bhagyashri. Okay, so this is say for example, this is you, okay, and you are ordering pizza online. So what is the flow, right? For first of all, you have to log in, right? You have to log in. You need to give your user ID and password. Once you give your user ID and password, then you land to the menu page where you select the type of pizza, whatever the pizza that you want. And then when you select the pizza, it goes to something known as cart, right? And from cart, you go and make the payment. And the moment you make the payment, the pizza get delivered to your home. This is the business logic, right? This is how that particular application works. Now, if I have to design this application, okay, if I have to design this application, you are a developer, okay, and you got this kind of in your organization, somebody's told you, okay, let's design this application. So what I can do, I can start designing means first of all, I need to code it, right? I need to write a code of it. So if it is something like if I have to code, I need to put the login logic in my code, right? My code will have some kind of a logic that will authenticate you, right? It may ask you the user ID, it may ask you the password, or it's maybe with your Gmail account, with your Facebook account, you can go and log in. So this logic I need to build in my program. Okay. Similarly, I need to build the menu logic, when you log in you should able to see menu. That also I need to write it. The menu should have type of pizza, prices, some combination offering and all, right? Then once you select the pizza, then we have to write the logic for the cart and so on and so forth, logic for the payment. This is when you write this kind of program. Say for example, this is my code and this is written in Python. Okay, Python, Java, doesn't matter. Just in this example, it doesn't matter, but just imagine it is written in Python. This code must be running somewhere, right? This code must be running somewhere. So we need a server, right? A physical machine to run this particular. Okay, this machine will be running this code, and people like you and me will go and log into Domino's.com, Pizza.com, something like that, and we'll go and log in and order pizza, right? This is you and me. We are sitting over the internet, right? We will go and log in to this particular application and order pizza. More or less, this is going to be the flow, right? This way of designing the program where we have written one single program, okay, and writing the code. This we called monolith way of running a program. Okay, this is known as monolithic way of running the program or monolith application. Okay, the term that I'm using here is monolith. Monolith means it's a one single program. Okay, monolith app is like it basically run as a single unit. It is just one single program that runs this particular application. Okay, monolith application is built as a single unit. Okay, single unit means what? This is one single program. Just give me a second. I'm searching for annotation. Yeah, this is one single program. Okay, it is written in one single language. It is one business logic that is having login, menu, cart, payment, and so on and so forth. All right. Now, uh, let's how to clear this one. Yeah, I'm not getting the option to clear this annotation. Just give me a second. Oh, it's here. Okay. Clear. All right. All right. Perfect. So this is till here. Everyone is with me. Is it making sense so far? All right. Okay, now if I have to deploy the same application, what are the challenges with this kind of approach? What could be the challenge with this kind of approach? Let's try to understand. When you deploy this application in a single application, in a monolith way, in a single logic, business logic, single program, there could be a couple of challenges. First of all, it has to be written over. It must be written in one single language. Okay. Is this a challenge? Could be a challenge. Maybe what I'm trying to say, if you go to, say, for example, any application, right? Let me go to some application right now. Uh, just 1 second. Say, for example, I'm going to bookmyshow.com. All right. This is the bookmyshow.com. All right. Let's say select any city here. So here you can see this UI, this we call UI, the user interface, where you can go and sign in, provide user ID, password, and then you can select movie, stream, event, plays, and all. So this is what the any pizza delivery application will also look like same. So what I'm trying to say, this is written in one single language. So if you write in single language, maybe the login UI, that is the UI that we have just seen, it may be written better in Java. Menu we can write better in Python. Cart we can write better in Node, and so on and so forth. That liberty is not available in monolith kind of application. This is what I'm trying to say. You have to write the whole application. Okay, you have to write the whole application in one single language. You can't write login in Java, menu in Python, cart in Go, something like that. It's not possible. Okay, so you have to write all the application in one single language. This sometimes, I mean, because every language comes with some advantages and disadvantages, so that you need to decide what language you are going to select. Second thing is, the challenge here is you cannot scale. You cannot scale, okay, the whole application. I mean, a particular part of the application. Okay. Say, for example, you may have seen, like, people order more pizza in kind of India-Pakistan match, IPL series and all, because nobody wants to cook food. So they may get more traffic, right? May get more traffic. They may get more people will log in and create more user. So I cannot individually scale login only. Okay. I need to scale the whole application or nothing. It's one or zero. I cannot individually scale all these business components. So these are the few challenges. People started thinking about it. Then this approach of design is changed. What they have changed? What got changed? From monolith approach, we move something known as microservice architecture. Okay. From monolith approach, we move something known as microservice architecture. What happens in microservice architecture? The same login is going to be running, but as an independent application. Menu will be running as an independent application. Okay. Cart will be like running as an independent application, and so on and so forth. Payment will run also as an independent application. So this is what we need to understand. Okay. All these are independent. It means it's a independent application, it's a different application, it's a different application. Okay. So all will be running as an independent application. And because these are the part of a big application, small chunk of a big application, that is the reason we call them as a microservice. Not the whole big service, but a micro level of it. So that is why we call them as a microservice. This login, menu, cart, and payment, we can run these application independently on on a bare metal machine also. Okay, we can run like as over a server like this. We can run on individual bare metal machine. That is quite possible. Okay, good, bad, or ugly, that we'll see in a minute. But we can run on a physical machine. When I'm saying server, it is like a physical machine, the bare metal. Okay, server, the physical machine. Okay, that is one of the options. Second option, we can run these machine on a VM, something like EC2 instances, right? I think everybody knows what is EC2. It's a VM that AWS offers, right? Virtual machine. I can run all these things on an EC2 instance. That is also quite possible. Okay. All these microservices I can run on an independent application as an EC2 instance, over an EC2 instance. But most of the time you will see that these microservices we run something over a container, something like Docker. Okay, if I see like Docker, I go to images, I just need an image of Docker. So this is also we can run our application as a Docker container. Okay, this is nothing but a container. This is most obvious choice. I'm not saying this is good, this is bad, or this is ugly. It's not like that, because it all depend upon the use case. What is my use case? Based upon that, I can select the deployment target. Maybe my target will be a physical machine. Maybe target is an EC2 instance. Maybe my target is a Docker container or any container. I've just given here example of a Docker container. Okay, we can deploy this application. But the problem in challenges start where, like, for running, if you want to run a login application, you are not going to run login on a single container. It's not going to happen because containers are ephemeral. They come and they go, right? They may get deleted because of any reason. If I'm running my login application on a single container, what will happen? If this is gone, nobody can log into my pizza delivery application, right? It's a business loss for me. So what we do generally, instead of running on a single container, in order to maintain the high availability, we run it on a multiple containers. Okay, a group of containers, 10, 20, 50, like this many containers. Okay, similarly, all these microservices will be running on multiple containers. Okay, because you have to log in, payment, delivery, everything. So what is I'm trying to tell you right now? If you are running any microservice application and on a container, there will be a lot of containers for you to manage. Are you getting the point? Okay. So this will be like multiple containers that will be running. So there will be lot of containers to manage. If I go to any microservice like Netflix.com, if I go to bookmyshow.com, this is also running on container. This is also running on Kubernetes. Okay, and all these are microservices. These are the small microservices. Okay, this is movie is one microservice, stream is another microservice, event is another microservice, so on and so forth. All these are microservices. You want to see, you can just click on, say for example, click on movie. Okay, you will see that the link got changed, movies dot something like. If I click on event, you will see that traffic is going to event microservices. If I click on sports, it will go to sports microservices. Okay, so the point I'm trying to make it here is, even if you go here or even if you go to amazon.in, okay, this is full of microservices. This is full of microservices. This is one microservice. This is another microservice, so on and so forth. All these are microservices. All these, there are, so what is the point I'm trying to make here? So there are so many microservices and each microservices runs on multiple container. So there will be lot of container that you need to manage. Okay. So this is where, in order to manage this container, we cannot manage it manually. Can we manage it manually? The technical answer is yes, of course we can manage it manually. but my life will become hell, right? Because it's very, very difficult to manage 500 containers. When they are getting down, we need to scale it, we need to patch them. Like, there are so many management activity that we have to perform. Then you may ask, like, what could be the management activity? Like, there are many things, like, we need to scale our container. We need to, if the container get deleted, we need to relaunch it. All those things are basically comes under the we need automation for. And such an automation tool is Kubernetes. Okay. Kubernetes is a container orchestration tool. What is this? Kubernetes is a container orchestration tool. All right. Orchestration means you may have seen, like, orchestra. So there is a guy who kind of no who kind of um, what I can say, maintain the, or no, let me go here. Not sure what this is. This is the guy, like, this is the guy who is kind of maintaining the coordination between all these guys, right? Like, if this guy is not here, you will hear the noise, not the music, right? But because of this guy, he kind of instruct everybody what to play, how to play, what should be the pitch, and all those things, right? Then we get a beautiful music, right, from the orchestra. So this orchestration word is came from the orchestra. So Kubernetes is an or container, okay, container orchestration. Okay, Kubernetes is a container orchestration tool. If I have to define, and sometimes we call Kubernetes in short form K8S. Why? Because there are 8 characters from K to S. If you can count the correct characters, U, B, E, R, I mean till A, there are 8 characters. So in short, we call K8S or Kubernetes. So what is Kubernetes? Kubernetes is a container orchestration tool. And if I have to define Kubernetes, I'll say Kubernetes is nothing, who is also called KTS, is an open source container orchestration platform developed by Google, and this is maintained right now. It is maintained by CNCF. What is CNCF? It's a cloud native foundation. It was a tool that is all developed by Google internally. Later they made it open source. Now it is maintained and now maintained by CNCF organization. All right. So till here, everyone is with me. I hope. Yeah. Good. So now we are going to discuss about the container, like, what are the different what is Kubernetes that we understood. We will discuss about the architecture of Kubernetes quickly at very high level, okay? Because in generally for this it requires a lot of deep dive, but we will discuss at high level. So Kubernetes architecture, there are two components. First we call control plane component, okay? This is control plane, and second component we call data plane, okay? This is known as data plane. Control plane is something like where we take all the decision. Data plane is your where actually the real work, like, where actually your application runs. Okay, where actually your pizza delivery application will run. That is known as data plane. If I go a little bit more deeper into this architecture, the same control plane and data plane, it is basically control plane control plane, or sometimes we also call master, and data plane we also call worker node. Okay, the worker nodes, like where worker node. Okay, where actually your application run. Control plane has couple of component. The one important component is known as Cube API server. Okay, one component we called Cube API server. This is one of the component. Another component of the control plane we called control manager, controller manager. Okay. Another component of control plane we called scheduler. Okay. And the important component we also call, there is a database component that we call etcd. etcd or etcd, whatever you want to say. All right. These are the 4 important components of the control plane. Data plane, there are a couple of components. One important component is we call kubelet. All right. And another important component of data plane we call kubeproxy. And one other important component is runc, or the container runtime. These are the 7 important components. Are these are the only component? No, there are a few other components, but 7 important components for a Kubernetes cluster. Okay, 7 important components for a Kubernetes cluster. This is the these are the components for one of the worker node. If you have multi-node Kubernetes cluster, like say for example 2-node Kubernetes cluster, so the same component will be running on the other node as well. Okay, if it is a 10-node Kubernetes cluster, then will be 10 these 10 node means 10 machine. 10 machines, like your container must be running on some machine, maybe a physical machine or virtual machine. This is known we call as a machine. Okay, the nodes. That is 2-node Kubernetes cluster, 3-node Kubernetes cluster, 4-node Kubernetes cluster, so on and so forth. Netflix running on 100 nodes of Kubernetes cluster. They have thousands of containers running behind it. Okay, so depending upon the kind of application you're running, the kind of load you are getting, we need to decide the number of nodes, number of container or pod in Kubernetes, that we call pod in Kubernetes. Okay, so this is an architecture of Kubernetes. Now we will also discuss about the component of Kubernetes, as a how these things are connected to each other. Okay, for this, what we are going to do is we are going to just just give me 1 second. Sorry, folks, I'm back. I need some water. Yeah. So this is right now the structure. Now, first of all, we will try to understand what is the purpose of Kubernetes, and we kind of understood what is Kubernetes, the architecture of Kubernetes. Then we'll try to understand why we need Kubernetes, or something like Kubernetes, right? So when you're running many applications such as microservice application, first is like Kubernetes, it will offer you self-healing capability. Self-healing capability means, say for example, IPL streaming is going on, and just because of any issue, there is some problem, and some of the containers got deleted or got because of any reason. There could be a number of reasons. Just imagine any reason. Maybe hardware issue, maybe the CPU is not enough, maybe memory crash or anything. Kubernetes comes with a self-healing facility, when the containers will get deleted in Kubernetes. And there is also, let me make it clear, in Kubernetes or in KTS, we don't call them container, we call them pods. Okay. So I'll just quickly tell you, what is the difference between container and a pod? A pod can contain multiple container within it. Okay. Pod can contain multiple container within it. Okay, what is the meaning of it? Say for example, I am running this. This is my pod. Okay, this is my pod. This pod can have one container. This is, I can say, C1. There are also possibility the pod can contain multiple containers. It can contain 2 containers. Okay, so this is the difference. There is a no in like generally in detailed discussion, I can actually talk about what is the reason for that, because for that we need a container background as well to understand. But I'll quickly tell you, the whole purpose of the container is to design a one business logic. Okay, the whole purpose of the container is to run only one business logic. What do you mean by that? Say for example, I have created a container for the login application. So it will run only the login application. But if I have a requirement where I want to understand who is login from over my application, more people log in from Bangalore, more people log in from Noida, more people log in from Delhi, or where is my customer base? So for that, I need to collect their IP address information. Can I build that logic also in login application? Technical answer is yes. We can build that logic in login application, but we don't do this for container. as a the whole idea, the whole purpose of designing the container is container will run one business logic. If you have dependency of business logic, what you can do, you can create one more container and run inside the pod. This is something like one, it will collect some information from this container and it will process some information, something like that. Okay. So that is why this is the concept of pod. In pod, you can run multiple container if you have a requirement. All right. Most of the time, we generally run one container inside the pod also. And we don't call container in Kubernetes, we call them pod. All right. So this is what, let me back to the why Kubernetes. So this is basically self-healing facility that Kubernetes offer out of the box. If your pod get deleted because of any reason, okay, because of any reason, if your pod get deleted, Kubernetes will automatically recover it. Okay, that is what we call self-healing facility. Another thing is auto scaling. Kubernetes offers also the feature of auto scaling. Okay, auto scaling means if, say, for example, Hotstar right now, Geo Hotstar, they are streaming IP. They were streaming IP, right? Say, for example, if this is a Hotstar server, say, for example, it is running on, say, for example, 10 pod. Just imagine 2 pod. Okay, during daytime when they are streaming their web series and all, their customer base may be small, right? Maybe 10 lakh people watching it, right? But at 7:30 when IPL gets started, this 10 lakh will become few crores, right? You may have seen like 23 crore people are live streaming it right now. When more people will start watching, they will make a request to my server. Each request will consume some amount of memory and CPU. So we need to scale. We need to launch more such machine. This is known as scaling. I'm scaling out. That is automatically done by Kubernetes. All right. Load balancing. That is also one of the features that Kubernetes offer. It will distribute the incoming request to the underlying pods. Okay. Because for each microservices, we will be launching multiple pods. So it will distribute your load across the multiple pod. That is known as load balancing. All right. And another is like infrastructure abstraction. That is also one of the feature of Kubernetes. Okay. Till here, I have set it up like the whole background of why, what, and why of Kubernetes. Okay. So now you tell me from here what we are going to do. We are going to create a simple application. Okay. We will go and create a uh, there are many ways we can launch a Kubernetes cluster. Okay, so one of them is basically is we called as Minikube. All right, we can launch Kubernetes over a Minikube as a Minikube. Minikube is nothing but it's good for learning purpose. Okay, and test purpose. And if you want to test something, okay, learn and test purpose, this is good. Why? Because it is one node Kubernetes cluster. In single node, it is basically one node Kubernetes cluster. In the same single node, the control plane and data plane will be running. Okay, it's not good for production deployment. Okay, it's good only for learning and exploring Kubernetes. There are many other ways we can launch Kubernetes where we can have multiple node Kubernetes cluster. But for learning purpose, Minikube is good. It's much more than sufficient. Okay, you can basically go and launch your Kubernetes cluster over here. Okay, so what we are going to do, I have a Linux machine. Okay, I have a Linux machine. Over this Linux machine, we are going to install Minikube. All right, we are going to install Minikube. So for installation of Minikube, there are some steps, some process. First, there's some step. First step is you need to install Docker. Okay, first step is install Docker. Okay, second step is install Minikube. Second step is install Minikube. All right, and third step is basically there's a utility that we called install kubectl or kubectl. Okay, what is this kubectl? Kubectl is a command line utility. Kubectl. Okay. kubectl is a command line utility line through which we can connect to our Kubernetes cluster. We can connect to our Kubernetes cluster. All right. It is something like, say, for example, you want to connect to Facebook, right? You want to open your Gmail account. You need some command, you need some client software, right? At your machine, you may be needing a Firefox, Chrome, or any such client software through which you can go and connect. It is something like that. kubectl is something like that, where it's a command line utility with which you will use kubectl to connect to our Kubernetes cluster. We will use kubectl to deploy our application on a Kubernetes cluster. So each and everything we can communicate Kubernetes using kubectl. So what is the step number one? Install Docker, install Minikube, install kubectl, and your Kubernetes Minikube cluster is done. Okay. So in order to install Minikube, or install Docker, what we generally do, you can go to here, install Docker. So here you can see uh, this is docs.docker.com. You can follow this link to install Docker. For all the version it is given here, if mine is Ubuntu, you can click on Ubuntu. The steps are given here how to install Docker. You need to just copy and paste. Click here, it will get copied, and you can install Docker. This is one of the way. And another way is, this is my machine. Here what you can do is basically you can have your something you can just type here Docker on a Ubuntu machine. If Docker is not installed, it will give you command to install Docker. apt install docker.io. This is one single command that also you can use to install Docker. So I'm not going to do nothing. I'll just follow this particular command. And before that, we will do apt-get update. Update. Let me do sudo. And the next thing is we will install Docker using this command. All right. So Docker installation is in how to verify it. You can just run Docker again. If you're getting this output, this is one of the layman approach to identify Docker is installed or not. If you just run Docker, if you're getting this command as a man pages and all, it means that Docker is installed. What is a more professional way? Docker hyphen B. It will tell you this is 27.5.1 version got installed. All right, so Docker got installed. Step number one is done. So Docker installation is done. Second step is install Minikube. For Minikube installation, you can follow Minikube documentation. You can just go to Google and type Minikube. Okay. You will see this document, Minikube start and all. You can select your operating system Linux. Okay. And you will see that this is how you can download and install Minikube. You can use wget command. You can use curl command to download the software. So what we will do, I will use wget command to download the Minikube. First, you need to download it. Okay. You can see it is downloading the Minikube software. It is something like you go and browser and click something and get download. It will get downloaded on your download in Windows machine. So in Linux, the command line utility is wget, or no, you can use most of the time. Sorry. So most of the time you can also use curl command, right? Or wget command, whatever command that you want to use, you can use it. And if you want more detail, you can just do man curl or man wget. We'll get more information about it. When this Minikube software, you can see Minikube Linux something got downloaded. Okay. Now what we can do, we can copy this particular thing to in your path variable, usr local bin. Okay. So I'm just copying this into usr local bin to my path so that I can run minikube command. And the next, also one more thing, that you need to make this as an executable. So you need to make it plus X. I'm giving the executable permission so that I can run minikube commands. Okay. So step number 2 is also done. We have installed minikube, downloaded minikube, and we have installed minikube. So this is also done. Now, what is step number 3? Step number 3 is install kubectl. How to install kubectl? In order to install kubectl, what you can do, you can go to the Kubernetes documentation, create kubernetes.io or create.io. Okay, this is Kubernetes documentation. You can click on document. Okay, you can see why Kubernetes, a lot of setting up cluster and all. So you can set up a cluster using this documentation as well. This will also give you step-by-step document. This is one of the place where you can learn Kubernetes in detail. Okay, and if you want to install, as mentioned here, install kubectl. Okay, so this will again take you to the kubernetes.io documentation installation tools. Here you can see where you want to install. What is kubectl? That I have explained it. And if you want to install, where you want to install on a Cube, Linux, Mac, Windows, where you want to install. I want to install on Linux. So I'll say install on Linux. Okay, and which version of Linux? You can just select, you can download it. This is a command. I can just copy this command and download. Here I'm using curl command. Okay, so you can use curl, download kubectl. So you can see it is downloading kubectl. It got downloaded. Unless you can see kubectl got downloaded. Now what you need to do, you need to make it executable and move it to your path directory. Path where in your path, right? Usr local bin. That's it. So kubectl is installed, minikube is installed, and your Docker is installed. So all the prerequisites are met. Now this is also done. Now what we are going to do, we are going to create our cluster. For that, we need to start minikube. Okay. And for this, we must be adding our user into Docker. Let me see what is my ID here. It is perfectly fine. This is one of my users. So let me change the prompt again. Here's one, let's say minikube. All right. So I have added my ID into Docker group. In order to start it, the command, in order to create the Kubernetes cluster, you need to do minikube, okay, start hyphen driver is equal to doc. Because we are using Docker as a driver for minikube. You can use many other drivers, like you can use Oracle VirtualBox also, and so many other things. So we are using Docker. So we'll mention minikube start hyphen driver is equal to doc. So it will take a minute or two and my cluster will be ready. Okay. Master support, how many nodes? It's not any limitation. You can support many nodes. I have seen 10, 15, 20 nodes of Kubernetes cluster. Okay. What is the difference between Docker and Kubernetes? Docker is a container. Kubernetes is a container orchestration tool. Okay. And if I have, what is the other question? If I have a query, how we can install Docker on desktop, you want to, I mean, you can follow the same method in docker.io documentation. There they have mentioned how to install Docker desktop also. Okay, that also you can follow the same link. Ubuntu, I mean, for Ubuntu server specification is something like it must have at least 4 gig of RAM and for 2 vCPUs at least. Okay, but for my case, it's little higher. It's like 4 CPUs and 16 gig of RAM. Yeah, you can set up a Kubernetes on Windows machine as well. Node is a machine on which pod runs. Okay. We can generally create multi-master for scaling. And if you're running inside the cloud, it's a managed service, then the cloud vendor will automatically take care of it. All right. So our mini cube, I took some questions because till the time it was, kind of answering. I mean, this is getting installed. So now our mini cube cluster is ready. So what we are going to do is basically we'll have this is our Kubernetes cluster. So in order to understand, whether my Kubernetes cluster is running, the command is, as I mentioned, kubectl get nodes. Okay, so this is basically uh, this command basically tell us my it's a mini cube cluster control plane and it is in ready status. So what happens when you type kubectl command? Okay, when you type your kubectl command, say for example in this case, this particular case, we are sitting here right now. We have taken our machine, say for example laptop. Okay, from our laptop, we connected to our virtual machine, that is a Linux machine. Okay, on this Linux machine, we have installed mini kubectl, right? We have installed kubectl. The moment you run kubectl command, the request goes to kube API server. Okay, the request goes to kube API server. And kube API server will authenticate and authorize you, like whether you are authorized to run this particular command or not, or you are a known user or not. That kube API server will authenticate and authorize you. And after that, whatever the command that you have run, it will try to run that command or run that particular request. Okay. So this is how it is connected. Kube API server, the moment where we run kubectl get node, what happens after that? The request goes to kube API server and this information, how many nodes and all those things, everything gets stored in the etcd database. So kube API server will be connected to etcd database. Okay, this etcd database, and the etcd database will have all our cluster information, how many nodes, how many, what are the nodes running, what are the nodes faulty, how many pods are running. Every information is getting stored over the etcd database. So this information is kube API server fetched from etcd database and displayed to us. All right. So this is how we have run, cube ctl get nodes and all. Now what we are going to do, we are going to create a deployment. We are going to run the deployment. Okay, how uh, here what we are going to create is, we are going to create a application, say for example nginx application. So what happens in Kubernetes, if you want to deploy any application, there are a couple of ways. Okay, in Kubernetes, uh, there is some approach that we follow. One is we call how to deploy application in Kubernetes. Okay, one approach we call imperative approach, and the second way we call declarative approach. All right, so imperative approach is something like we directly do it from the command prompt. Something like we'll directly run the kubectl command, and during the in the command only we'll mention all the information. In declarative approach, what we do, we create a manifest file. We create a file where we mention all the information, all the in detail, what I want to create, what is the name, how many, what should be the image, and all those things we mention in this manifest file. And this file is basically a YAML file. We write in YAML language. We write everything in YAML. And this file we pass to the this particular file we pass to the Kubernetes using kubectl apply command. Okay, we'll run kubectl apply command. Whatever we have written in this file, it will get implemented. Okay, this request will go to Kube API server. Kube API server will read all those information. If it is possible, it will go and deploy everything. If it is not possible, you will get some error or something like that. In an imperative way, what is happening? We don't write any file. We mention all the information inside the command. This is sometimes is preferred approach, declarative, because we have the file. We can whatever we have written, whatever we have created, everything is already documented. That is the point number one. And maintaining and changing anything is again very easy. You just need to go and remodify your file and reapply it. So any modification is also very easy. Okay. Here in imperative way, everything because it's done from the command prompt, it's very, very difficult to manage the things. Okay. Manage the things, something like, run if you want to change anything, you need to, and if it's very difficult to take the backup what you have done. Say for example, today I have creating using imperative way. If after 1 week somebody asks what you did, I won't able to recall, right? But if I have written a file for that, I can read my file and can tell this is what we have done, right? So this is better approach, safe approach, declarative. So what we are going to do, we are going to write a declarative file for one of our deploying for Nginx. Maybe we can say Nginx YAML file. So let me just copy the file. Let me open my text editor. Just give me a second. Okay, so what we'll do, we'll create a YAML file, okay? And this YAML file will apply to the Kubernetes to create our first application. So this is the YAML file, okay, where we are creating a deployment, and we are creating a name of the deployment is nginx-deployment. And this is going to create pod for me, and it will going to create 3 pod for me. Replica is equal to 3. And this each pod will have container running it, and the container is going to use nginx image. Okay, and that is going to listen on the port number 80. So what is the first thing that we need to do is basically we need to create this file here. So what we'll do, we'll go to our server, we'll say vi file name. You can take name like you can put any name, but make sure that it should be ending with YAML or YML. Okay, it must be an YAML file. Now I'll paste my code here. It's a very simple code. I'll explain the code in a minute. So here you can see this is the file is ready. What is the next thing? If you want to see like kubectl get pod, you will see that no pods are running right now. Okay, but what we can do, we can deploy this particular file, and if the command is kubectl apply -f and the name of the file. What is the name of the file? The name of the file is this. Okay, actually the path of the file, we are at the same location, so that is why we are giving name of the file. If you run it, it says deployment got created. Now if I go and see kubectl get pod, you'll see that my 3 pods are getting created. It is in creation phase, creating. Wait for a minute. You can say it is running. Two out of 3, 2 are running right now. It is like 3 pods are running right now. Okay. So all the 3 pods are running right now.
Sorry, sir. Sorry to interrupt in between. Actually, screen is like not visible to many people. Can you please like pin it?
1 second. Is it visible now? Preeti, are you able to see my screen?
No, actually, mm, guys, is it visible to you? Because to me, it is not visible. Yeah, it is
Uh,
showing very small screen.
I mean, small screen that I can change the setting. I mean, the fonts are so small that I don't know why it is showing as a small, but
But I can check it on live. It is going well, but here in Zoom, I think there's some issue.
that I don't know why it is small. I mean, you can put it in your main screen. Okay, in this Zoom, you can change it. You can double click, it will become your main screen.
Yeah, actually, I have tried everything. Mhm.
Now that is what
I
I
think
really,
now it is visible, I
you
think.
need to change it. If it
Yeah,
is
yeah, I think now it's visible.
if your name is showing big, my name is showing as a big, you can change it. In
It's
Zoom,
visible now. It's visible now.
you can, yeah, you can see Jashri saying no issue for, so it's problem. You need to change the setting. From my side, I can't do much.
So it's visible.
All right. Yeah, so this is, you can see this is right now, I have 3 containers running right now. Okay, so this is what I want to show you folks. Like this is something we have created a container. Now, if I go and say kubectl get pod, it will list down the container. If I go ahead and delete this container, say for example, if I want to delete this particular pod, how can I delete this particular pod? I can say kubectl delete pod and the name of the pod. The pod got deleted. If I go again and run it again, can you see that again there are 3 pod? Can you see that? 1, 2, and 3. We have deleted this pod 2x8gl, right? 2x8gl we have deleted. This pod got deleted. For this pod, another new pod 74b4z just got launched 5 seconds before. So that is what auto healing feature. Even my pod is getting deleted, Kubernetes is making it available for me. Are you folks getting it? Self-healing feature. Let me try one more time. Let me delete any other pod. kubectl delete. Let me delete 2 pod this time. I'll delete dhzfcf something and gtnn4. Right, the last few characters. Both are like a 3 minute, 3 minute before. So I've deleted both the pods. Now again, if I go and say kubectl get pod, you can see the new pods are getting replaced by the old pod. So that is the self-healing feature. Okay. Are you folks with me? Yeah. Okay. So even we can also scale the pod. Okay. We can say kubectl get pod or get deployment. So this is the deployment that we have created. I can also launch more of pod. I can say kubectl scale. I want to scale my deployments. I'll say deploy and the name of the deployment. And I can say hyphen replica is equal to 5. Okay, so in spelling is replica, CA. 1 second, replicas or something. Replicas, if I'm not wrong, as 5. Yeah. So replicas, not replicas. S was missing. So now you can see kubectl get pod. You'll see that I have 5 pod right now. 1, 2, 3, 4, 5. And these 2 pod just got launched when we have scaled it. Here you may ask, like you mentioned that it will automatically scale, but you're manually scaling it. Yes, right now I'm manually scaling it because it's a mini cube, it's a test machine. When I'll be running this on AWS or Azure or Oracle Cloud, there it will automatically get scaled. If my load will increase, more people will come and start streaming, watching IPL match. based upon the load, it will automatically launch more pod for me. Netflix series get launched, maybe say for example, new Panchayat series is getting launched. More people will go to Amazon Prime and watch it, right? They will get more traffic. So they need to scale their infrastructure at behind, right? Otherwise, what will happen? It will get stuck. Nobody will watch it. So that automation is already that we can build in Kubernetes because it's just an 1 hour session, so we cannot show everything here. It even it's a very high level discussion that we did right now, but this all those things are possible. Okay, so one more thing that I would like to tell you here is just give me a second. All right, so this is something uh, here when we run this command, the information is getting stored in HCD. Okay, so what we can do here is we can see, say for example, if you go and see kubectl describe and deploy, and the name of your deployment is nginx-deployment. Okay, this is something. Sorry, describe. This is all you can see, the detail information is coming, right? This is something like what is the name, when it got created, a lot of other information, log, everything. So everything is basically getting stored in the HCD. This is your database where everything is getting stored. So when we are running any kind of a get command or something, some information that you want to fetch, it will come from HCD. When you modify anything, everything will be rewritten here, updated here. Okay. Yes, with this, I am done. I mean, I'll be open for question. Preeti, over to you.
Okay, thank you so much, sir. Actually, we have one session feedback form, and I would like to request everyone, guys, please do fill it out. If you want any particular session or anything, there you can put. And still, if you have any question, you can ask. Rahul, before ending this session, is there any piece of advice you would like to give to our audience or the people who are going to start their career?
Yeah, definitely. I mean, I can say one thing like, Kubernetes is very important part of Docker. DevOps, sorry. And whatever is right now, the any kind of application that you're seeing, whether I have named like multiple applications, right? I have named like Hotstar, I've named like Netflix and all. So all these things are backend is Kubernetes because I have very closely worked with those folks, so I know like how they are running, what they are running. Even the bookmyshow.com that I've shown is also an Kubernetes cluster. So even your chat GPT, LLM models, backend is Kubernetes. So Kubernetes is a very important topic. Okay, and for if somebody wants to advance, want to learn DevOps, but Kubernetes is not the only thing in order to know Kubernetes, because in 1 hour Kubernetes is not at all possible. It's a subject by itself, right? So we need to spend a lot of time to understand this. But the point I'm trying to make, Kubernetes is not the only thing. First of all, you should be knowing DevOps in a very proper manner. Like you should start from version control system like Git, GitHub, containers, Docker, or then Kubernetes, then something like Ansible, Terraform, this kind of whole path that is going to, the combination of all those things is going to help you. Okay, but out of all these tools, whatever that I have named, Kubernetes is one of the very important.
Okay, thank you very much. Thank you, and thank you everyone who have joined us today. We are really grateful, and thank you so much, Rahul, for delivering this session. We truly appreciate you taking the time to share your knowledge with us.
Yeah.
And guys, if you would like to revisit the session or share it with others, the recordings are available on our LinkedIn page and YouTube channel. So until then, take care, stay curious, and keep learning. And still, if you guys have any question, you can reach out to us or directly Rahul. He will definitely answer you. Thank you once again, Rahul. Bye bye,
Thank you.
everyone. Take care,
Thank you.
Rahul.
Thank you.